So this week I'm very happy to introduce Howard Trottier. So Howard is one of our faculty colleagues at SFU, although formally now a professor emeritus of SFU. He is well known for his theoretical high energy physics work, in particular lattice QCD, but he's a hobby astronomer, and particularly, I guess, in his retirement, he's got more and more interested in this. And as you'll see, he's a pretty professional amateur astronomer, very serious about astrophotography, taking some fantastic images, which are basically like screensavers that people have on their computer. So he's going to talk to us today about astrophotography. So it's all yours, Howard.
Well, thanks so much for the invitation, Doug. And boy, if you're going to stroke an astrophotographer's ego, you couldn't have done more than that. It's funny how pictures kind of take over your life. So let's see how this goes. So yeah, I put quotes around amateur because amateur in this context can mean somebody who loves what they do but has great skill, not necessarily me, but other people. And so my talk is going to be sort of mainly personal, but with some look at what other people do in this kind of business. And so these pictures, I'm going to get back to them and tell you what they're all about as I go through it. And so I thought I'd just sort of fill in a little bit about who I am. So I'm a physicist, yes, but I'm not an astronomer, at least not a professional astronomer. So this is me back when I first joined SFU. So I call that my version 1.0. And so as Doug mentioned, I'm a particle theorist. And when I'm giving a public talk, I always like, because it's to start to explain what subatomic theoretical physicists do is a week-long discussion. And so I'll say, if you know Big Bang Theory, think Sheldon Cooper. So kind of very, very broadly the same area of physics. Although I like to say that I'm not nearly as smart as this guy, but I have much better social skills. And so, as Doug mentioned, yes, I worked in what's called lattice QCD, among other things, but mostly in that area as part of, for quite a period of time, an international collaboration that did a lot of very, very exciting work. But very quickly after starting at SFU, I didn't really know how much I would enjoy teaching until I started. And then I really ended up feeling like maybe the biggest part of my career in many ways was teaching. And to give you an idea of how I would teach, I had a philosophy, which was I had no shame. Okay, 3, 2, 1, trigger. I'm screwed. So, I've shown this video when I lecture in front of an audience, and so I can sort of feed off of how people react. I certainly enjoy watching that again. Back to my sort of labeling scheme. This is when I finally got tenure. So as a professor, it's like version 2.x, various varieties. And 2 years ago, I actually took early retirement. So I'm kind of like version 3.x. There's Patrick Stewart as Professor X. I continued to teach for a couple of years and manage the SFU Observatory, which I'll talk a little bit about later, on a post-retirement contract. But I'm now finally retired as of this summer, just passed. And so before I tell you about my personal astrophotography, I thought I'd try to give you a flavor of what the different varieties of amateur astrophotography are out there, and it's really a tremendous range from people who spend lots of money, like me, on equipment to take deep sky images, and people who spend absolutely no money on it but use creativity to produce really wonderful work. And so amateur astrophotography is, and once you're in this for a while, you might think the first thing you'd say is, well, it's Astronomy Picture of the Day, which is a website that's been run by 2 professional astronomers since the summer of 1995. And this is not the very first APOD. This was the second. The very, very first APOD was actually a computer-generated diagram. So in terms of images, this is the very, very, very first image. And it says right here, it's the Pleiades star cluster, which is from a very large professional observatory, Mount Wilson. So I'm going to take you forward in time about 20 years and show you what amateur astronomers do by way of the Pleiades now, and there's lots of different varieties. Here's one of the very best people who does astrophotography. So 20 years later, there's the Pleiades. And so you wouldn't even show your friends or your family what the previous image. You'd be too ashamed in today's world. This is the kind of thing that people now do with changes to the field that have taken place over the last 20 years. And so question, before I do that, I want to just zoom in. So this looks beautiful just already at this scale, lots of color, nebulosity, and so on. But the resolution is also there, and you can zoom into this thing. In many cases, the APOD that you see on the homepage is not the whole thing. You have to kind of like zoom into it. So I'll do that sort of manually. So there we go. There's into a part of the cluster. So really breathtaking color, detail at many, many levels, all kinds of texture and so on. It's really an extraordinary thing to look at. Okay, so what happened in those 20 years? And so a number of things have happened, in particular in terms of this kind of deep sky image. I'll tell you a little bit what happened. So several things. First of all, large aperture telescopes became increasingly affordable over time. You can still spend an awful lot of money for a big telescope, but you can get gear that didn't exist 20 years ago today for not much money. It's not just a telescope, you have to have a mount that can drive it in a very precise way. So there are precision computer controlled mounts that are common. There are, one of the biggest ingredients was the development of CCD cameras for like a mass market. So large format cameras that have onboard electronic circuits to cool them, to reduce the thermal noise. And then long integration times. So this fellow spent 20 hours of integration at the telescope to produce this image. And 20 hours these days is actually not a lot in this kind of business. And finally, I won't have much to say about this, although in many ways it's almost the most important. Taking the image is one thing, getting the raw data is one thing, but to produce something like this, which is kind of more like art, requires very sophisticated image processing techniques. And I picked this image in part because of the guy who produced it. His name is Robert Gendler. He's an amateur, he's a scientist in a sense, he's a professional MD, but he was one of the people who really led the charge in terms of the development of CCD camera imaging and also the development of very sophisticated image processing techniques. So we're going to see this guy again later on in my talk if all goes according to plan. Just to get my watch so I keep track. So if I'm going too fast or mumbling, please let me know. Okay, so for the next couple of slides, I want to tell you about, as I said, the different varieties of astrophotography. They're out there, and in almost every case, I'm going to resort to APOD, and this is something which you look at every day. So here is another example of an APOD. Oops. Oh, so sorry about that. What did I do? Okay, here is an example of an APOD, pardon me. Okay, so one more example as you saw. So there is this very short couple of sentence description. It's really quite wonderful, written by these two professional astronomers, Nemiroff and Bonnell, and it's with links to all kinds of things. So just the captions themselves, especially for the public, are really, for somebody who's a scientist, it's really quite wonderful. So among the many things that you see which does not require much in the way of equipment are breathtaking celestial terrestrial composites. And this is a very recent APOD. And I've been to Crete several times. This is absolutely gorgeous. And so here we need to really zoom in to see what's going on. And so an APOD, if you hover over the image, it'll pop up like illustrations or labels. And so I'll do that for you now. So all kinds of things, the sky, there's the Big Dipper, Polaris, Vega, Antares, Jupiter, Saturn, and then amazingly, there's Comet Neowise. And there's a guy lying by the beach. This thing requires incredible planning and creative insight. The camera is probably not that sophisticated, but the image processing that brings all this and stitches it all together is something which you're not going to do overnight. This person is incredibly skilled. And if you try to do something like this yourself, you'll know right away, oh boy, it's not just trying to take the pictures, it's much more than that. So these kinds of composites, you'll see these on APOD all the time. They're absolutely beautiful. And then the things that are quite a bit simpler, just sort of creative new ways of telling familiar stories. And so here's a shot of somebody who's bicycle riding with the moon on a ridge with the moon in the background, something we sort of, could all imagine or have done doing. but here it's presented in a way that just makes you see it anew. And so again, no really significant equipment is required, but takes that vision and processing to put it all together. This is one of my favorites, and so you don't even need any equipment at all. The person who produced this video that I'm about to show you, he's an artist by training. He has no science background, but he had the vision to take a series of images from Cassini and stitch it together into a movie that I showed in my astronomy class every year. And I just, every time I see it, it sort of makes me stop in my tracks. So this is about 2 minutes or so. So I hope it plays well in the sound. You'll let me know. So really a totally alien environment that's presented in a way that's just so breathtaking and beautiful in such a strange way. Doug, do you mind if I ask, can you still hear me and see did you see the video?
Yeah, it was good.
Yeah, there's a little bit of lagging, so I apologize for that. Okay. So again, you can see lots of this kind of videography, just things that I mean, I would never think of producing a thing like this, nor would I have the videography skills to put it together. So you just have to admire that kind of creative genius. I'm going to get personal in just a second. So there are those of us out in the world who chase total solar eclipses. If you were lucky enough to see the one in 2017, I don't mean from here where it was partial. The difference between a partial solar eclipse and total is the difference between night and day. They're totally different experiences. And so this set of images in this really amazing almost austere environment gives you a sense of the progression of a total solar eclipse. You see one of these, you want to see it again. And you know, totality, onset totality is just something that is hard to describe, very, very hard to put into words. So it turns out that thanks to my oldest brother, Lauren, who started this in 1995, the family has gone on a variety of total solar eclipse chases. And so this is our family last year when we went to Oregon to see the total solar eclipse. We put ourselves right on the center line. But what I want to do is go back to an earlier trip that we took in 2010 to the South Pacific, to the island of Tahiti island of Hao, just a 50 kilometer long strip of dirt in the middle of the ocean. Really kind of a crazy place to go to see the eclipse. And my brother Lauren, who's over here with these goggles, he's been shooting videos of totality now for quite a while. And this fellow over here, Eric, who's the husband of my niece Sylvie, when we went to this eclipse that was there first, he decided to put a camera on us while my brother put a camera on the sun. And so this is going to give you a sense of the kind of reaction that seeing a total solar eclipse can induce in you if you have no shame, and Trottiers don't really have much of a shame. So this is again about a 3-minute and change video. Hope this works. Here we go. My job was to edit it all together. That was my sole contribution. So kind of in 4 parts.
It's getting dark. Look around.
Do we take them off? Do we take them off?
Not yet. Not yet. There's a
It's gonna get way better. Streamer, holy totality! Amazing, amazing. Okay, so look at my look. So near between 11 and 12 o'clock, you can see some prominences.
Yes, I can see it.
Wow.
With the eye.
Yeah, you can see it in the eye. Wow! Look at the size of that streamer. The totality! Totality! 1, 2, 3. Where's Mercury?
Mercury.
Mercury's right there on the right. On the right. Lower right. Yeah, there's Mercury. Look at the prominence. Look at the prominence. Holy cow. Wow. Diamond ring. Diamond ring. Diamond ring. Diamond ring. Don't stare too hard. Look away. Oh my God. Holy shit. To the diamond ring. Wow.
My first total eclipse. 3 minutes, 27 seconds of totality. Awesome.
You really can't trust pictures, right? Because this picture of you over here that Sylvie took makes you look very into it.
Yeah.
And I think, basically
I wasn't into it.
You were totally like nonplussed.
I know, you can see from the recording, but I really didn't enjoy myself.
Everybody was screaming.
Yeah. I was gonna leave early actually, but I didn't want to be rude.
You didn't want to be rude.
Yeah, it was more social convention than anything. Yeah, Alexandre, I think you enjoyed yourself less than me actually.
No, I didn't.
He was totally not into it.
Yeah.
He didn't shoot any pictures. He didn't do any screaming.
I saw you take out your computer and start playing video games.
That's right. He's like, this, the virtual world, wow, is so much better than this.
Yeah, I know. You can get this on the computer.
I can
You can get it for hours and hours.
Any old YouTube shit.
Yeah. Wow. So that's 3.5 minutes of
so you were
time you've spent in
so fast.
Didn't it?
It did, yeah.
That was my son Alexander when he was 16. So again, I hope that sort of came through okay. I'm sure you've gotten your share now of Trottier family screaming. So as I said, one is not enough, even a couple are not enough. In fact, we were all planning, a big chunk of us, my family were planning to go to Chile. We were all booked, flights, hotels, whatever, for the total solar eclipse that's coming up in December. But of course, COVID put the nix on that. But we have our travel budget back from the travel agent. We're already planning now to be in Mexico in 2024. It'd be very tempting to go to Montreal, where I was born and raised, although I think the totality line misses it, and the weather in April is not very good up there. So we'll probably go somewhere in Mexico. But yeah, so when you see one of these, you want to see it again. And by the way, the camera does not have nearly the same dynamic range, not close to the human eye. So you see way more, much more prominent corona with rich texture structure you cannot see in that video. It's just absolutely alien experience if you've never seen anything like that before. It's just a bolt from the blue. Okay, so back to more conventional kind of astrophotography. So this is an example of what we refer to as planetary lucky imaging. And this person, Damien Peach, is one of the world's foremost planetary imagers. His images are absolutely drop dead amazing. And sometimes he uses fairly big telescopes in great locations. Sometimes he uses a telescope in his backyard. This telescope, I don't actually remember which one he took. This might have been a sort of backyard telescope. You see Jupiter, great red spot, and you even see some detail in Ganymede. This is like it was taken by the Galileo spacecraft in '95, flying past Jupiter, around Jupiter, just astonishing. And so this is actually something you can do to a very high degree with a small telescope and a very simple even webcam. People use webcams to do these things in the beginning. Now, just to give you a sense of what, if you don't know about this already, what's lucky about it, I couldn't find any raw videos from Peach. So my apologies to him. I'm going to insert one of my own raw videos. I'm still a real noob when it comes to doing planetary imaging. And so this is a series of frames that shot maybe 50 per second of Jupiter. And so you can see some structure in the planet. I mean, this is the kind of thing you might imagine seeing by eye through a telescope. If you ever look at a planet by eye through a telescope, you'll see jumping up and down. Of course, that's because of the light refracting through the atmosphere, different pockets of density, different density atmosphere. So the image jumps around and blurs. And every once in a while, the atmosphere in that direction might settle down for just a tiny fraction of a second. And if you're at the eyeball, to the eyepiece, you'll suddenly see this detail and just before you can really take it in, it's gone because of the seeing gets poor again. So the idea with lucky imaging is you shoot lots and lots and lots of frames, and you use software. The software for this is actually free. And the software will scan through the stack of frames and pick out as many of the best ones as you want to use, and then you can stack those and sharpen them. And again, to go from something like this to that, this is a giant leap in technical skill and image processing skill. And I'm not there yet, but I want to try and get there. So that's what's lucky imaging is something where you can get started early without much gear, but you have to be prepared for the fact that like anything, good people, great people make it look easy. It's not. So just to zoom in on this thing, see, there we go, a little closer in. Absolutely astonishing the level of detail that's in this, and he's done. You can look him up on APOD. Work he's done, rotation movies and these things, just amazing. And of course, he's not the only one. There are quite a few people who do really good work. Here's another thing you can do in terms of lucky imaging. You can image the ISS, and you see a thing like this for the first time. I don't believe this. This can't be true. And you go look this up, and you'll see that all kinds of work this group of fellows, they are very, 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 very skilled once again, but this is astonishing detail. This is the only image I think I'm showing you that is not from APOD. It's from another site that I've since become also a big part of as a member. It's called Astrobin. And this has 10,000 members or so, thousands of people who shoot astrophotography. And if you join, you'll see like a constant turnover of images from people every day. Something new pops up, images, beginners, newbies, people do drop dead imaging. It's really a fabulous place to go to see work. And I post now my stuff there, which I didn't do in the past. There's 50,000 members, pardon me. How many do photography? I'm not quite sure, but most of them do. And so that's where I took this thing from. This is quite a recent posting, actually, although it's dated 2010. Anyway, another thing I want to draw your attention to in terms of Astrobin. So you might ask, okay, well, I don't want to spend any money on equipment. I don't have any equipment. What can I do? And I'll come back to that a little bit more in a second. But one thing you can do if you do have some money to spend, say a restaurant eating money, not to buy your own equipment, you can actually pay as you go for remote access to really absolutely first-rate amateur gear. Not just big telescopes and cameras, but in locations, Chile, in New Mexico, in Australia, places where the skies are absolutely beautiful and sharp. And so you can pay as you go and take images and then process them. And you can find a whole bunch of those kinds of sites that are listed on Astrobin, or you can just Google around and find. So that's one way to go to get your feet wet if you don't want to, try to buy equipment of your own. Okay, so APOD, I've been shooting deep sky images for almost 10 years, and I'm going to try and tell you a little bit about my personal career in just a second. But as things turn out, I got my first APOD just earlier this month. It was a kismet, as if, the gods of astrophotography heard Doug's invitation to me to give this talk. And so deep field images, this is something, again, now that requires, equipment and good equipment to do, kind of like the Pleiades that we saw from Robert Gendler, although this is a different thing. This is a field of view that I've been obsessed over for a very, very, very long time. It's the Hercules cluster of galaxies. And so again, the paragraph here that's been written by the APOD scientists is just very beautiful to read. So these are island universes, a mere 500 million light years away. And so I just was blown away when I finally got this. And if you talk to anybody who knows me, I've been whining for years about when APOD is like a lottery because there's so much good work out there. And as time goes on, the level gets higher and higher and higher, especially in this kind of like long focal length, long exposure, deep sky photography. It's just the work that's being done is ever increasing in quality. And so just earlier this month, as I mentioned. So here again, I'm going to zoom into this thing so you can get a kind of better look at it. I'm not sure how well that shows up. But hundreds of galaxies, many of them are colliding or interacting. This one, supermassive black hole, must be very active right now. It's a giant jet that's shooting out, maybe another one in the other direction. Just, again, so this is, again, not to wax too long on my own picture, but this kind of deep field view is something that is just, sort of draws you in. And so I've been wanting to shoot this for 6 or 7 years before I finally really had the opportunity to do so. Okay, so another way to do this hobby, which does not really require any money, except maybe for a little bit of software, is to process professional images yourself. And the guy who wrote this article in the Sky and Telescope, July 2012, you can find lots of resources online, just Google. It's this fellow Robert Gendler, the guy who did the Pleiades picture that I showed you before. So this guy spent years developing techniques of data acquisition and processing, which amateurs across the world like me copied. And after a while, he got a little bit tired of doing his images from his backyard. The picture I showed you before was his telescope in front of his driveway. And so he turned to professional archives, of which there are plenty, not just the Hubble, but almost every major observatory, spacecraft. Juno has been very popular with amateurs lately. And so you can find out people to tell you, how to get at the images, how to download them, the calibration files and all that. Although you try it yourself and you'll see, okay, the Hubble took the pictures, you don't have to worry about that. You can't get much better than that. But the image processing is something completely different and requires a very high level of skill to produce the kind of results you're going to see. So here's one of the earlier ones that he did, actually not that early, 2018. This is the horse head. It's a very popular object with amateurs. I've shot it myself. And so this is a whole bunch of Hubble data processed by him and published in APOD. And you can do the same thing too, but be prepared to learn how, which is part of the joy, is learning how to do this sort of thing. You can zoom in and zoom and zoom. And I saw him give a talk on this picture actually. And he was like, I wanted to take pictures where you could zoom and zoom and zoom and zoom and zoom before you reach the resolution limit. And this is, this you can't do much better than the Hubble. This is an extraordinary close-up look at the horse head. So there are all kinds of things you can do. So many amateurs do research with their own gear, and that's not been such an emphasis of mine. I have my own research career. Often it's in niche areas where people can do very interesting and important work sometimes, and I'll give you an example in a second. Amateurs collaborate with professionals. And so the American Astronomical Society, this is the leading professional society for astronomers in the US. And they have an annual award, Chambliss Amateur Achievement Award, and here are a bunch of recent ones. I just highlighted a few. What do? They do variable stars. They search for supernovae. They do ultra deep imaging. I've seen this guy, Gabani. You go look at his work, he'll knock your socks off. They study asteroids, astrophotometry, and all kinds of things. And so, and often with very modest equipment, but lots of time. And as part of groups on their own. And so there's a whole other avenue you can open up into with your telescope and CCD camera to do work, not necessarily original research, just fun projects. And I've done some of those with students. And so research is a big thing. And pro-am collaborations are also a big part of that. And here's a third and last time I'm going to talk to you about Robert Gendler. There he is again. And so this was the Andromeda Panchromatic Survey that resolved over 100 million stars in the Andromeda galaxy. And I didn't look too deeply into the literature to see what the relative contributions were, but it's clear that this played an extremely important role in processing those images, given the other work that you've seen him do. And so just here's an example of a press release image. So this is a Deep Sky Survey and Robert Gendler. You'll find this somewhere on the Hubble website. And so there is the field that they imaged in such depth, and set it in context to a broader image. And guess who took that image? Well, okay, that was Robert Gendler's image of Andromeda. And if you open up a first-year astronomy textbook, chances are you're going to find his picture in there somewhere of the Andromeda galaxy. So that's there, but that wasn't his contribution, was the image processing. So I thought I'd take a second just to zoom into this thing, because it is really just mind-boggling. So there is a close-up view, and here's an additional close-up. That's the same field of view I just zoomed into with 6 different star clusters that they looked at. And the scale here is just 150 light years from 2.4 million light years away. Absolutely breathtaking. And so, just to give you an idea of what the high end of amateur achievement is this kind of collaboration with professionals. Really, just amazing to contemplate. Okay, so I think time is sort of going. Okay, so astrophotography, as I've already indicated, is very personal for me, and I thought I'd just give you a little bit of a history about what that's all about. So actually, I like to say that when I fell into astrophotography, I fell very deep, all of a sudden, and it did a bunch of things to my personal life, rearranged my professional career. I'll give you a sense of that. It took over my personal life, and it also had the very happy fringe benefit of transforming the life of my family. Along with my personal life, all because of almost by accident, really. Most of this is just by a set of flukes, which I'm very fortunate to have had. And so, just to tell you, my background is rooted in amateur astronomy. There's like my beta version, 1976, graduating from high school. I went like a head of hair. And so I was born and raised in Montreal. Went to West Hill High School, and at some point I got myself this telescope. Back in the day, this was about as good as it got for an amateur. It had a clock drive. This is like one of the very first telescopes that were sort of affordable, that would track the stars. I mean, just unreal. And so this is all, of course, visual astronomy, although some people did photography. That was not me. And so I spent most of my later years in high school not thinking about studying, but thinking about this, what I was going to do, and planning my observing sessions. It was like day and night, all the time. I had my star charts under my desk in class. It was just kind of crazy. And then, funnily enough, after I graduated high school, got into university, I just sort of, astronomy fell off. I fell off the cliff. I didn't do it anymore. And I used to wonder why. I thought, what happened to all that passion? And here's one sort of thing that happened to me fortuitously, is that I ended up inheriting the Intro to Astronomy course from Professor Lee Palmer, who taught it for many, many years. And so when I started teaching this course in 2003, after a little while, I thought, well, maybe I should show students, the night sky. And I got persuaded the department to get a telescope. This is a Mead Schmidt Cassegrain telescope. And I started hosting students outdoors, very small groups of students, to take a look at the night sky. Oh, and along the way, when I ordered this thing, by this point, I was completely ignorant, absolutely stunningly ignorant of what had been happening in the amateur astrophotography world. I had no idea. I was watching APOD. I never even checked to see carefully where were all those pictures coming from. Like more than half are amateur. Thought, geez, maybe I should get a camera and see what that's like. So I got this 0.5 megapixel camera. My guide camera has a chip that's like 5 times that size. It's a tiny, tiny little chip. And I plugged it into the telescope. I took it home so I could learn how. And just to show you where I started, that's my very first deep sky image. And you probably can't even recognize, even if you know astronomy, what the heck that thing is. It's the it's the Orion Nebula. And so, I got a person laughing here, because this is like, at the time for me, this is like, oh my gosh, you can get color in this city. It's like, and this was like 1 minute of exposure or something. It was just absolutely mind-blowing. This is where I started. And once I could see, I love visual astronomy by eyeball to the eyepiece, but this was like a completely different dimension. The level of richness and color you cannot get by eye, even through very large telescopes. So this just caught me in a very, very big way. That was 2007. And so I'm hosting student star parties and stuff like that. That's all going on at work. But then in the meantime, it takes over my life. And My family and I traveled out to the Okanagan in 2008 for the very first time because I heard amateur astronomers do photography and deep sky viewing out there. And so within a very short while, we actually put a down payment on a lot outside of Osoyoos and started to build a what we call a cabin in the sky, a rural country house for my family to go to, along with an observatory. And there's the structure finished. There's the moon in the background, beautiful skies, very, 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 very dark skies. And finally, the scope was ready for use in the spring of 2010. And so this is now a big upgrade from the scopes that I've been using before. Not just that Meade telescope, but a aphochromatic refractor that I got for use at home. And so this is now, this kind of equipment, you know, it's not cheap. And I'm lucky enough to be able to afford a thing like this. You know, 20 years ago, you couldn't buy a thing like this. It didn't really matter how much money you had to design, not just the telescope, but the mount and the camera, total transformation of what's possible. So this might be the last video. This is me, the very first time that I plugged in the motor to test the telescope out.
Yeah.
That's my mother-in-law in the
Welcome
background.
to the Cabin in the Sky Observatory. Oh, yes, a video, Ma.
Hi, Ma.
Cabin in the
My
Sky
wife.
Observatory. I'm going to control the telescope to listen to it go.
House, beautiful observatories, beautiful telescopes,
Hey,
You see it moving?
people.
yeah.
Oh my God.
Isn't it nice, Ma?
Moving, eh?
Look at that. And here comes, oh, wait, you got that going?
I got it going.
Woo! Cabin in the Sky Observatory!
Hey, Susie.
Plane whale.
Susie. Here, Susie, look.
Girly, come here for a sec. So that is a plane wave CDK 17-inch astrograph. This is a Paramount ME. This is the mount, which is the Paramount. And that's controlling the telescope, which is an awesome telescope. And look at this big giant steel pier here, 45 inches high. Look at Susie's eating snow.
Susie. Hi.
The observatory, the telescope.
Yeah,
Enjoy the snow.
and I'll give it again.
Look.
Isn't that awesome?
That's fantastic, my love.
So this is 2 years from getting that Meade telescope and setting it up in front of my house in the city and shooting the Orion Nebula. So just, you can see how quickly I dropped into this thing, and it's not an unusual experience. And so for the next 6 or 8 years, I got very, very serious with that gear and took a whole bunch of pictures. This is all I thought about. I mean, work and this, family, okay. And I was also able to publish, not an APOD, I tried, but for some reason it just never quite clicked. But the very first sort of serious picture that I took was of the Horsehead, which we saw in glorious detail from the Hubble before. Sky News is Canada's magazine of amateur astronomy. It so happened that they had their 20th anniversary calendar, and they put my Horsehead on the cover, which just blew me away. So that was kept me very, very, very busy. And it had the fringe benefit, as I indicated, of changing my family's life. My son was a teenager at the time, and so it really played an important role in our family. Driving out there, it's a 5.5 hour drive there and back on weekends, and we'd often spend the summer out there. And so it had an impact on my family life. It's really kind of hard to describe. So we're incredibly fortunate to be able to do a thing like this, but it would not have happened if I hadn't done that camera, and from SFU and all that. Just this parallel universe, we don't have anything like this as part of our family life. And meanwhile, back at SFU, I was still also very, very busy with now, teaching astronomy outreach became one of the biggest things that I was doing in my work. And by 2015, we opened the Trottier Observatory on Burnaby Mountain campus. And it's not just an observatory. The most important part in many ways is the science plaza that the observatory anchors, which is meant to convey the importance of science and wonders of the night sky to the public community that comes to visit, and to our students and staff, faculty. The fact that the university gave us this location, which is right next to the AQ, which is over here, is like prime real estate. This was a tremendously big deal. So it has my name on it, although I was a person who had the vision for this and tied it all together, and building my observatory in the country helped me prepare for getting equipment and what to do with this thing. But when I think of the Trottier Observatory, it's not me, it's another Trottier. mentioned already, is my brother Lauren, and I want to introduce him to you. In fact, I'm going to let Ted Chernecki of Global BC TV introduce my brother Lauren. This is a video from the year before when SFU opened a related to Trottier, a facility related to this one for public outreach. So.
See what happens here, right?
SFU is on a mission to find the next great cluster of star students, and it's doing it through the long lens of a telescope in this brand new science lab. Today, students from nearby Highland Elementary were the first to use it, as SFU announced its latest scientific instrument, the Trottier Observatory, a $4.4 million dome and telescope to be built right on campus.
For many years now, SFU has been delivering a program called Science in Action. It's designed to take our knowledge of science and take it into the community to help kids get excited about science and learn about science.
The guy running that program is SFU physics teacher Howard Trottier in blue jeans, who happens to have a rich brother.
Okay, so we're watching this, like, what? I have a rich brother. He can't do that on public TV, but of course he did, and it was the right thing to do. And I just love showing this thing. And so just to finish it.
A rich brother who made his fortune as the co-founder of Matrox Computer Graphics out of Montreal. He remembers clearly at age 11 how he was inspired to study electronics, and now hopes he and his wife can inspire someone else.
Through programs like this, one hopes that they're going to get that spark and it's going to last a lifetime and maybe even lead to good careers in this field, and people make big discoveries that could be important.
It's not just my brother, it's my brother and my sister-in-law, his wife Louise, and their girls, Claire and Sylvie, that support us. My brother is, I think, the smartest guy that I know. So he's not just an electronics engineer, he's a renaissance man of science. It's just amazing to talk to this guy. And he and his wife are philanthropists. Climate change is one of the biggest, the biggest thing that they and their daughters do by way of philanthropy efforts to mitigate climate change. Because of the pandemic, they completely reorganized what they were doing to fund very aggressive public health measures and research. Very extraordinary people with this commitment to public education and other things. And so I think we're getting near the end. And so I've kind of reached now my new chapter. This is what I like to call the final frontier telescope. And so it's kind of a double meaning. This is now another upgrade in technology for me. This is about as serious an amateur scope as you can get, with a very serious payload back here as amateur astronomy goes, and a location. This is a double meaning. The telescope explores the final frontier out in space, but it's also in a very extraordinary location. It's kind of like final frontier. It's called the Sierra Remote Observatories, which I've known about for many, many years. It was founded in 2006. So this is located in the foothills of the Sierra Nevada. It's actually only a little more than an hour's drive outside of Fresno. I visited there last November before the pandemic had hit. The skies are fantastically dark. There's a small little light dome in the direction of the city, which is mostly shielded by these ridges. And so they have these giant roll-off roof, individual roll-off roofs, like the one that I had in the Okanagan, but these other ones that have multi-telescope facilities. And as it says up here, their clients include astronomers from universities, space policy institutes, and astrophotographers who can afford to put a telescope here, which is not cheap, of course. And I'm tremendously fortunate to be able to do this. And so this gives you an idea of what you'd find on the inside. Things about this site that are just astonishing. Well, okay, seeing is one of the things you're constantly worried about. You want sharp images, and seeing is really where the limit of amateur astrophotography of this sort of nature is reached, because most people are under skies that are like 2 arcseconds of seeing. They just don't get professional level seeing, and we can't afford adaptive optics systems. But this site is an extraordinary place where they routinely get 1 arcsecond seeing, and you can tell right away the difference. This is like a factor of 3 increase in resolution compared to what I could do before, with incredibly dark skies at 290 clear nights a year. I mean, think about how many nights we get out here. And so plus they have on-site technical support that turned out to be extraordinarily helpful. And for me, doubly so, because I started planning this thing in May of 2019. And I visited there in November, and the telescope was set to arrive in May. But of course, by that time, the pandemic had hit, so there's no way that I could go down to the US to install this thing. And the technicians, they basically did it for me. Even the company that built the telescope, their people couldn't come out to do it. So these 2 young but smart and very competent people, they installed the telescope, and I'm in this building, 11 over here in the corner. And so here's some videos. These are choppy because this is streamed live over the web. And so it's 4 different camera views. Oops, sorry about that. Showing with a crane outside, and these 2 guys steering the telescope in and putting it on the mount. And not only did they do that, and because I wanted to put the whole thing together as I had done with my telescope in the Okanagan, but I couldn't. So I'm going to give you a quick sense before I exhaust you of what kind of equipment I have. So they put the whole thing together for me with, my talking it through parts of it and so on. But without that, this would all still be in a crate somewhere, and I wouldn't be using it for like who knows how long. So just to give you a sense of what this thing is, now this is a tremendous and extravagance for one person, pardon me. And to justify it to myself, I plan to make time available on this thing to my colleague Joanna Wu, who many of you at ABC would know, who took over managing observatory. He's teaching astronomy, and who does research, and so for student projects and so on. This will keep me connected to SFU. And part of the choice of equipment was with that in mind. And so just not to bore you too much, but okay, so this is from PlaneWave. I didn't identify them before. So they really revolutionized the development of large aperture telescopes with fantastic optics at a price level that was like a factor of 2 or more or less than what you would have paid before. These guys, they're really tremendous breakthrough. So this is a 60 centimeter telescope, 0.6 meter aperture, and it's pretty fast. It's f6.5. I have a electronic instrument selector. It's a giant, basically flip mirror with a pass through to the main camera, but no mirror, but then you can redirect the light. So there are 3 different ports. The main thing is this imaging camera, 60 megapixels. This is a new design. CCD chips are on the way out. The manufacturers are not going to make them anymore. So this is like a bleeding edge new design called scientific CMOS. And so there's the camera. You mount the filters for various reasons outside. So there's a filter wheel. As fabulous as this telescope and the mount is made by them too, the tracking system is to take the kind of images we're talking about, you need to auto guide. So you have to have a guide camera. There's the guide camera. And there's also a spectrograph. This is a resolution 1000 classical slit spectrograph from a company in France called Cheliac. These are a bunch of guys who are engineers by day and lovers of spectroscopy by night. So they really are revolutionizing the market for amateurs who want to do spectroscopy. This is, you can do a tremendous amount of very cool things, as we already have this one at SFU. I got that at SFU before getting it for myself. And also planetary lucky imaging, a special high frame rate camera for doing lucky imaging. And this is something which I still have a lot to learn about. So this is a whole suite of instruments. And again, with designed for student projects, they'll be able to do spectroscopy, imaging, and so on. And I've spent now months, getting the system running and so on. So that, which has just been absolutely thrilling. And so just to give you a quick sense of what it's like, this is a time-lapse thing that runs through the night. This is about 2 minutes, minute and a half. So you see the roof opens automatically. They have a whole weather control system. You don't have to worry about it. It takes care of it. So it opens about an hour and a half before it gets dark. Let things cool off. And so here I'm going to show you quickly sped up tracking. This is looking to the south, the one at the top, and you can there is the centerpiece of the central part of the Milky Way going across the sky. So this is kind of, you can watch this, you watch this. These cameras are publicly available. So I'm the one in the back. Okay, and when you're done, you park your telescope, and then maybe you take some flat fields, and the roof closes again. And so it still just gets me very excited just to watch this thing happening. And I like to watch it open every night, just because. And so after all those years of learning how and so on, I finally was able to get an A+. I won't bother with this. This shows you the control of the observatory, but I think we'll leave that out. And so after all that time, miraculously, miracles, I finally got this A-pod. And so that brings me to the end. So thank you for staying with me through all this.